Today we'll discuss about the laser and its application in periodontics. Laser may consisting of a visible light which having a light of having a higher energy as well as a lower energy source of frequencies. We know that light consists of radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. The mainly historical perspective is 1916, the Albert Einstein postulated the theory of laser, that is a spontaneous and stimulated emission of radiation in his good theory. That's strong. In 1954, Thomas and Gordon, they given a term called as laser. 57, Gordon and Gordon introduced the term laser. Phenomenon wherein molecules excited by a source of energy ultimately create an organized pattern of energy that can be directed in a specific field. So the laser stands for L is light, A is amplification, S is stimulated, E is emission, and R is radiation. Historically, in 1960, Theodore Neyman, they given a term ruby laser, the form of ruby laser, 61 Javan, helium neon gas lasers. In 1960, for QC, they given neodymium lasers. 1965, carbon dioxide lasers, 85 Myros, neodymium, yagnium, carry for the lasers for use for carriage removal. 1987, that is FDA approved lasers. In 1997, the PM that is approved for the use of heart tissue surfaces. Helium and neon, HEN is for helium and neon. HOYAG, that's called chromium, yttrium, aluminum, garnet. NDYAG, it's a neodymium, yttrium, aluminum, garnet. And erbium, yttrium, aluminum, garnet, ERYAG. What are the major properties of a laser? The first one is a monochromatic. It's a beam of a single color which is visible if its wavelength is outside of the visible part of the spectrum. Next is coherent, identical in physical size and shape. Collimation, that is mainly produced with all the waves that is parallel to each other. What are the components of a laser? Then actually the components, first one, there should be an active medium. Second one should be a pumping mechanism. There will be an optical resonator, a cooling subsystem, and a control subsystem. Active medium consisting of gas, solid, and liquids, especially gas, example is argon laser and carbon dioxide laser. Solid is a diode. Neodymium magnesium is also a solid phase. Erbium magnesium is from solid phase, and red dye is a liquid phase. Usually defines the laser types. Now the population inversion is the key. The population inversion is more number of atoms that are in excited state in the ground state. That is the laser mechanism what we explained over here. Laser delivery systems. The first one is neodymium lasers, having a small flexible fiber optic system with bad glass that deliver the laser energy to the target tissues. Carbon dioxide and erbium lasers are absorbed by water, which is the major components of conventional glass fibers. So constructed with the special fibers, it's capable of transmitting with semi-flexible hollow waveguides. Small quartz or sapphire tips are attached to the laser devices for contact with the target tissues. Lasers may have different fiber diameters, handpieces, and tips. Emission modes. Two types, pulse on and off modes and constant mode. Pulse on and off mode, they have gated pulse mode and diode, and carbon dioxide lasers are used as a gated pulse mode. Next is free running pulse mode, that is neodymium and erbium magnum. And in constant on mode, that is continuous wave mode, diode and carbon dioxide lasers can be used. These are the emission modes. Operations parameters mainly focused and defocused. Relatively small spot size on a tissue size we call it a focus, and a big spot size on the tissue surface we call it defocused. Laser operation, the first one is a contact. Tip in contact with the tissue, they concentrate the delivery of laser energy. Charge tissue formation at the tip and the ductal feedback is available. Non-contact tip is kept around 0.5 to 1 mm away from the tissues, and the laser energy delivered at the target tissue is reduced. No feedback, only tissue. So what are the laser 4 tissue interactions we can get it? First one is the reflection, transmission, scattering, and absorption. Reflection is redirected off the surface and there is no effect on the target tissues. It is dangerous and it could be redirected to an unintentional target. Example is carbon dioxide laser. The right hand plants as well as the left eye. Second is an absorption. It is most desirable effect, primary and beneficial both. It's an amount of energy that is absorbed depending on the tissue characteristics such as pigmentation, water content, and laser wavelength. So these are the different types of lasers in the wavelength. LX and right 377 nanometers in type is a solid type of lasers. Argon is 488, around 515 nanometers. Helium is 630 nanometers. Diode laser is 810 to 980 nanometers. Neodymium magnet is 1064 nanometers. Holmium Yagnan lasers is around 2120 nanometers. Erbium family is around 2090, 790 to 2040 nanometers. Carbon dioxide lasers having a wavelength of 9300, 600, 10600 nanometers. Next is transmission. In transmission, directly through the tissue with no effects on the target tissues and mainly dependent on the wavelength of laser lights. Next is scattering. It weakens the intent enhancement. Heat transfer to the tissue adjacent to the surgical site from an unwanted laser effects. But it is more useful in facilitating the laser cutting of the composite resin. What is photobiological effects? Photothermal. Photothermal means it is transferred mainly into a heat. Light is also transferred to heat. The primary photothermal laser tissue reactions are incision or excision, ablation, or vaporization. Hemostasis or coagulation. All these interactions are based on the spot size. So, what are the tissue temperature and what are the observed effects? In tissue temperature is 37-degree normal temperature of the body, 37 degrees. There will be hypothermia and edema. There will be herpetic lesions in the use of herpetic lesions and ulcers as well as bone lesions. Okay, it's more than 60. There will be coagulation of protein denaturations. Okay, tissue color from magenta to dark pink or healthy conditions at 70 to 90. Welding and denaturation. The temperature is 100 to 100. There will be vaporization and ablation. And if it is more than 200, there will be carbonization. Next is photochemical. Photochemical occurs when the laser is used to stimulate the chemical reactions. An absorption by chromophores of a specific wavelength fluorescence the tissue using carries detections. It is also interested in biostimulations. Now, what is a biostimulation? The stimulatory effect of a laser light on a biochemical and molecular processes that normally occurs in tissues such as healthy and brittle, increasing the circulation, collagen, osteoblastic and fibroblastic formation, which initiates the healing. Stop inflammatory responses and allows them to move the infected circular. So next is photomechanical. Photo disruption means breaking apart of structures by laser lights. And photoacoustics means the removal of the tissue by shockwave interactions. And photoelectrical, that is protoplasmolysis, that is tissue is removed by the formation of electrically charged ions and the particles in the semi-gaseous high energy state.